I'm excited now to welcome Mr. Rob Gerard, Principal Technical Marketing Engineer, and Jeff Harbert, Director of Strategic Alliances for Data Protection at VAST. Rob and Jeff, it's great to have you on. Take it away.
Thanks, David.
Thank you very much. Glad to be here. So, for those of you who don't know who VAST are, we'll do a little bit of a background as to why we're here and some of the advantages that we believe we're bringing to the table when it comes to ransomware. And then we're going to do a little bit something different. So you guys had a lot of conversations, a lot of information here throughout the day regarding software approaches to addressing ransomware, mostly trying to avoid a ransomware attack. But from the perspective of VAST, it's what happens when you get attacked, right? How can we help you get that data back as quickly as possible? So you see here is recovering from ransomware in a flash. Now, to start here, a little bit about who we are and why we're joining you. So my name is Jeff Harbert. As mentioned, I am the Director of Strategic Alliances here at VAST. My background is about 25 years of backup and recovery, really on the services side of things, most recently working with a company to help develop ransomware services, right? How can we help build and solve those problems from a services side of things? But now with here with VAST is how can we take that same concept and apply it to the technology world? So you'll see here, Rob's going to walk you through some of the more technical aspects of this, but let me turn it over to Rob quick to introduce himself as well.
Hi there. Thanks, Jeff. Rob Gerard, Technical Marketing Engineer with VAST, also known as Lab Monkey. So I get a lot of opportunity to play in the lab, work with customers, and validate a lot of the solutions that we're doing here. So really thrilled to be on here today and get going, Jeff, and then I'll jump in and get on a soapbox and geek out on some of the technical stuff.
Perfect. Thanks. So one of the things I want to start with is just a little bit of who we are and background, right? We are not a backup solution. In fact, VAST started really trying to address workloads like high-performance computing and AI workloads. But over time, as we realized what we could do with our solution, again, it's an all-flash universal storage platform, we realized that actually it starts to solve a problem in the backup recovery space that previously couldn't be addressed, right? We are not just a backup solution, right? Our whole point of this is to be able to provide multiple workloads in the same platform. And you'll see that from a ransomware perspective, we think that brings a unique position. It enables VAST to be a key component of any ransomware recovery solution you build out there. So when you look at kind of what's in the market today, you know there are plenty of options, right? And all of them have trade-offs, benefits and trade-offs, right? So from a tape world, right, and I've been doing this for a long time. When I started, tape was the only solution we had available to us. Worked really well for large sequential writes, but it took a long time to actually recover data, right? So actually getting to that first byte of data usually meant calling Iron Mountain, having the truck bring it back, inventory and put in the library. Look, great for air gapping, right? It's a natural air gap solution. It does solve that problem, but being able to recover from it at large scale is a challenge. So mid-2000s, talk about purpose-built backup appliances, hey, that solved that first access problem, right? Getting to that first byte for restores worked really well in a purpose-built backup appliance. But when you started thinking about having to recover lots and lots of data in parallel, that deduplicated data on spinning disk creates a bottleneck, right? It actually doesn't perform well at this scale. Let's talk about cloud, right? Another great solution if you don't ever want to recover it. If you want to just be able to put your data someplace as an all long-term archive, cloud works great for that. But if you had to recover from a ransomware side of the attack, you'd have a really hard time doing that. So we also know there are other flash solutions out there, right? We are an all-flash solution, like some of the other ones you've heard today. But we think from our perspective, our deduplication technology gives us a unique advantage both cost-wise, and you'll see here in a few minutes in terms of recovery aspects as well. So why does that matter, right? When you think about what the technologies previously provided for you, it's the left-hand side of this slide. Generally speaking, tape or purpose-built backup appliances, or even the cloud, are designed to repair an individual user error, or maybe a technology or hardware failure of some sort. So recover a single file, recover a single system, recover a single database. Those systems work well for that. But in the ransomware world, as you guys know, you don't want to recover one system at a time. You want to recover them all at a time, right? So the whole function of what you're trying to restore has changed. That use case is no longer an individual data set is now everything in your environment. I've worked with multiple customers who have had challenges trying to do large-scale ransomware attacks because the architecture was from the mid-2000s, right? A purpose-built backup appliance was designed for backup, not designed for restores, and we had to change the script, flip that script for the actual purposes in terms of restores in the ransomware world. This is where we think VAST comes in and provides a whole different solution for you. So, to start, right, we are an all-flash system, exabyte scale, which really means we have the ability to support any of your capacity requirements out there with the same solution. We don't have multiple models, right? And in fact, Rob's going to go into a little bit more in terms of our architecture. We call it a disaggregated shared everything model that allows us to expand compute or capacity independently. What that really allows us to do is provide really large solutions or very flexible solutions for throughput, things that meet those needs. We are not, how do we make the data mover go? Hold on. There we go. We are not a software product in the sense that data mover perspective, right? So you can see here we work with all of the leading solutions out in the market. So any of those ones you might be using, a Commvault, a Cohesity, a Rubrik, a Veeam, a Veritas, we work with, right? So we are a target for those solutions. But what makes us unique is we really do focus on that ultra-fast restore capability. In fact, our restore times, our ability to read data from our solution is about 8 times faster than our backup speeds. So when you look at traditional systems, like a purpose-built backup appliance, usually their restore speeds are somewhere between 20 and 25% of their backup speeds. So ultimately, we're about 50 times faster and able to recover data. But what that really means is you have to think about the architecture very differently. You have to approach restores, not just backups, right? You have to design for that, make sure you have enough capacity, network capacity, data movers in the environment to actually support those type of restores. So the question is, how do we make that work, right? Because, hey, it's all flash. And trust me, when I joined as a former backup administrator, I said, there's no way I can make backup on flash make sense economically. Well, that's where our actual approach around data reduction comes in, right? It really is an unprecedented ability to reduce data, which allows us to store all that information. But even then, our read speeds are still significantly faster, even though it's all been reduced. It allows us to store that information on the system. But like everything else in the world today, obviously it's all about cyber, right? So what have we done from the perspective of our platforms to secure it? So a little bit about indestructible snaps, so a little bit about our security features as well. I'm going to turn it over to Rob for that conversation. But then it gets really interesting in terms of some of the things we can do around multiple workloads on the same platform. So Rob, maybe take it away here.
Great, thanks a lot, Jeff. So first things is, we'll get a build, there we go. Well, I just want to go through some of the ransomware mitigation features that are in the VAST platform. So we've got snapshots, and those snapshots can be configured as quickly as every 15 seconds. We have very customizable ways to export shares for SNB and exports for NFS and S3 buckets, and we can isolate these by VIPs as well, so virtual IP. So we can put these into different networks and have a whole bunch of different controls on it, which adds some flexibility. We can do that through virtual IPs on the same VLAN trunks, and we can also do physically separate to different networks. And I'm going to get into how we do that and how we can exploit that on a VAST system to go even further. We've also got FIPS validated encryption for data at rest. So that's all the data and all the metadata. And this encryption is FIPS 140-2 validated security ciphers. We also have indestructible snaps, which I'll go into a little bit more detail on the next slide. And then we've got some newer stuff coming right now. So NFS-v4 with on-the-wire encryption is just landing in our next version, which is just DA'd right now with a directed availability, and should be GAing shortly. Then we've also got an enhanced protocol audit in there, which is helpful for discovering what's going on in your environment. Later on in the year, we're working towards some inline ransomware detection, so in the storage platform itself. And there's some interesting things that we're doing there. And then taking the snapshots and being able to clone them and do fast restores and recoveries of those presented in different ways is coming in the release after that. And with the indestructible snapshot, this is like Worm, but with a twist. So it is very much like a snapshot in a system where it's immutable by nature. But this is set up in a way that if it's taken manually or with a schedule, that snapshot can't be deleted from the system. So it's locked in there until that retention time is up. Now, in the event that this was, someone just testing that or needed to undo it, there is a way to unlock that so that it can be deleted prematurely, or so that the schedule can be altered after it's initially set. And this involves VAST support and 2 people from the customer side. They generate a key, send it over to VAST, and there's a multiple factor authentication there involved to make sure that this is legit, in which case both the customer and VAST together can change that policy and delete those snaps.
Rob, before you go on, curious as to
yes.
The indestructible snapshots from the data protection world, right? So from primary storage world, I think it makes sense to people, but in data protection world, how do we recommend customers actually use these?
Sure. So these are good kind of just in case availability. Like this isn't Plan B. Like this isn't your primary line of defense. This is into Plan C territory where you've now got a rogue admin. You've got something that's compromised much further. Your backup software has been compromised. And so let's say that, so for ransomware, there is a lot bigger return on an investment if, if the threat that someone's giving somebody has weight to it. So if someone says, hey, your data is encrypted, we won't give it back unless you, pay the fee, they may not be too conservative, like, that's what you think, I've got a backup, whatever, get lost. And in the event that backup was compromised, this is a way to secure those even, so that that can't be compromised underneath the system.
Yeah, exactly. I think our recommendation is that because of the way we use these snaps, you can integrate them with your backup solution, like say a Commvault, right, with a workflow, for instance, that actually can run a indestructible snap right after the backup is done, and therefore protect your backup images. So that even if someone does come in and delete the Commvault data via Commvault, we know we can get it back to these indestructible snaps, right? So that's a hugely compelling use case around those indestructible snaps on the data protection world for sure.
It is, and with backup data, you're loading a lot of data into it, so it can be very potentially costly. And we believe that we have the best data reduction in the market today to reduce that and make that as minimal as possible. And that, of course, includes all data that's in the system in this huge namespace, and that includes snapshot data as well. Now, what can we do in the event that we have to recover from ransomware? And there's some sort of instant operations that I want to bring to your attention. So what do I mean by an instant operation? Well, I mean, like, leave a copy of these VMs that are ready to go. So this would be like your warm copies that you might use with your production array. You might have some replication there. The problem with the replication alone is that when you do something bad inside, delete things, encrypt things, that data movement is also replicated. So you want the ability to kind of roll back. So you can have these different points in time, and using a lot of different backup vendor software, we can do a recovery, or even a recovery and then a incremental restore to that, so that we don't have to take all the time it takes to do that big bulk restore. Now, we do have very fast restore speeds, but where do you restore to? So this is one way that you could have some VMDKs ready to go so that you could cut over and use it. And I have a few more slides of some ways that you may leverage and use that in terms of Cyber Recovery Vault or Clean Room.
Hey, Rob.
Now, the other thing I
think it's important.
Yes.
Sorry. I think it's important to note, right, that as I pointed out at the beginning of it, right, we are a universal storage platform. So while backup and recover traditional model works really well with Fast, again, obviously we can restore data very quickly, we clearly have the ability to do other workloads as well. And that's really where the benefit or the power of these interoperations come in. So if you've got VMDKs already available and recovered and ready to go in these recovery pools, you now have the ability to spin them up instantly, right? There's no going through your backup product to actually create a live mount and bring that system back. So ultimately, you'll be bottlenecked by your backup application. So in this model where we actually can have these VMDKs ready to go and available immediately, it creates a whole different paradigm. I don't have to worry about it as much. Now, again, I put my marketing hat there. I apologize. I'll let you go back into the technical aspects.
No, that's okay.
I'm much more interested in that.
That's okay. Also worth noting that when you're doing that, you are not eliminating the ability to use those vendors' instant recovery features as well. So those can also be leveraged to where they couldn't if your backend for your backing up to doesn't have good performance. There's no way that even these instant recoveries are going to give you anything at a relatively good amount of time to bring it up, let alone storage demotion that off. And I've heard customers taking days and weeks on other products to be able to spin those up and bring them off. So we have this ability to use all of the flash underneath in all these HA enclosures in this one big namespace. And our front-end container nodes, while you can use them all, you can also split them up for some isolation to guarantee that operations from one don't impact another. And so in this diagram here, I'm saying, okay, here's our backup pool. Here's our data movers leveraging that, writing stuff into there. And then we can have a recovery pool, some dedicated ones that are there for the ESX host to connect to it directly, to run these data stores out of, and also restore to. So there's no reason that you can't pull from the backup pool with your data mover and write it into that recovery pool. And you might be asking, like, why would you do that? And the reason you might do that is because the system that you originally backed up may not be available. It may not have space. And you're not ready to wipe it and say, no, I'm getting rid of it. And you may not be able to wipe it because for legal reasons, for cyber insurance, potentially you have to keep that around or leave it around to do a separate tape of it, maybe for preserving it in this infected state to prove that you were in fact infected. So there's a lot of reasons why that may not be available, and having a really fast system that you can restore to is not something that everybody has capacity for. And what makes this even better is having all that data already in there, even though it's in a different format, the proprietary format of the backup apps, most of the data is very, very similar. Even though there's different forms of compression and dedupe and stuff, the vast forms of data reduction can make that very economical and not require 100% amount of space to do those recoveries. Now I want to introduce you to something called the VAST Airlock. This is a concept that is like an airlock. You start to enter an airlock, you have to close the door behind you before that inner door can open. And most systems could never do something like this. They're a design where the logic and the brains of the storage are intrinsically tied in the same box and tied to the media itself. Now, in a tape world, you can take a tape out of the drive. It's now air-gapped, and then you could walk into a clean room and you could drop a tape into a drive in that clean room, and that tape is never in both spots at the same time. Now, if you start to take a system and do the exact same thing, and we want to have it in both, all of a sudden we're not air-gapped anymore. So this is a way that we can allow those front-end CNOs to service our production network, our source network, and then through private InfiniBand network back to the D boxes, which is where the flash sits. The flash sits there, served up only the C nodes. We could shut those front-end C nodes down. Now there's no access at all to that data in that D box, and then we bring up the C nodes on the that are attached to the same thing, where those C nodes had never touched the source production network, and there's no way that they could have ever been infiltrated. And then from there, we can leverage that as our clean room, or use that as a mechanism for moving that data to yet another site over a private network or secured network that does not allow that other site to touch any of the production sites. So this is sort of like a swing gate to go between the two, while it never connects them live at the same time at any point in time. Almost like a dead drop of data, and logically it's like taking out my shelves, my disks, and moving them and putting them in a completely separate system, except that the system can be on and wired, and there's mechanisms to prevent anything from getting it. Everything from shutting down ports on the switch to controlling VIP access, but also just the pure point that it's right in there. Okay. And I saw some stuff coming through the chat, but I'll let my colleagues go and hit that, and I'll proceed here. And we will provide written answers for the stuff that is coming in chat. And actually, there was one here that said, hey, does instant operations include data as well as VMs? Absolutely. Depending on the format that you're doing it in. But essentially what we're saying is we can recover here and then do staggered recoveries to it to increment it. So those could be in the form of, replication and snapshots that way, or through traditional backups. If this was a NAS backup files, you could do that. If this was Oracle backups and you had them back into the native Oracle format, you could live mount NFS and read those and mount that directly from an Oracle server. So how would we use this Airlock to build a clean room? So first of all, our clean room is on the right of this slide, and on the left are our C nodes, our container nodes that are in a good functional state, and they're taking all the active network connections. These network connections can be live clients, accessing user shares. They could be data movers if this is used for backups, and writing the backups into this. And then we've got another container that never touches production network, stays completely separate, and there's no way to go between the two on the network in any kind of live fashion. And this one can be set ready to read those same disks underneath from this big composable flash cloud. Now let's say that we're compromised on our production side here. Now what we can do in the state that we're compromised is we can shut that whole network down, right? We don't want it to get out anywhere. We don't want it to get in. Let's just shut it down, contain it. And this is a point where, when you're calling to shut it down, things have already gotten pretty bad and you're trying to figure out just how bad. So when shutdown happens, this backend can remain active. There's no way to access these enclosures on the back end. And what we can then do is bring up that standby C node or C nodes, the container nodes, however many we've allocated to it. Let them come in and then access all that data. And in that data, we can access live data. We can also access all those snapshots and all the immutable ones. So at this point, this clean room can now be set up so it actually doesn't have any access anywhere else. And we can start doing some of our recovery operations there, have a farm of compute there for either its containers or ESX or bare metal boxes that are ready to go with the data that's inside. And this is how that clean room can then be leveraged. And so that was how we can use the VAST Airlock. Oh, go ahead.
I think a question from Bradford around, will that recovery data set be malware free? And Bradford, to answer the question, no, we can't guarantee that. But the really interesting thing here about that is, if you think about a recovery process, generally speaking, you have a red network where you've been infected. You then build a yellow network where you're unsure about the data, right? You have to do some type of scanning of that information in some way, shape, or form, right? Then you've got your green network where you say, okay, I've gone through all this data. I know it's clean. I can move it over to my green network, right? By having this clean room kind of concept, you're effectively creating a yellow network to start, right? Now you can do all of your scans, any type of forensic analysis of your data sets in a functionally separate network, right, without bringing everything else up or in a way that can actually impact things. And then as you scan it, you can say, okay, is this stuff clean? If so, great, move it to my green network, start my recovery process. But in the concept of adding these VMDKs into a recovery pool, you might be able to, because of our deduplication technology, be able to store 30, 60, 90 days worth of VMDKs for effectively the cost of one VMDK, right? Because the data reduction should allow you to keep multiple snapshots of that or multiple versions of that with very little data storage consumed. So you should be able to scroll back in time very quickly and easily decide, okay, here's a clean version of what I can use, and bring that online and move it into your green network as production environments.
Okay, and adding to that is yes, malware could be in that data and it could go and get loose in the clean room. Now, if it were let loose in the clean room, that immutable data on the underlying VAST system is still immutable. We haven't, this isn't a tape that we just moved over, that clean room is compromised, that it could now wipe the tape. The underlying data in this VAST box, even if the clean room were compromised, all of the stuff that was configured for any kind of snapshotting and immutability remains safe and clean and unaltered by that, infected side. And I think with that, we have just to wrap it up with a final slide. I'm waiting for it to load. There it is. And so just to summarize on universal storage for data protection, we want you to rethink recovery. This isn't just getting data out. This is getting data out very, very fast. This is also the ability to read and write to portions of it without having, 2, 3, 5x factor amount of storage needed to do that. So we're looking at 2 and 3 type methods of accessing the same underlying thing. We want you to rethink scalability. We have a single namespace. It gets bigger and better. The bigger it gets, the better it gets. Comes in more throughput. We could add more performance by adding more of those container nodes, which we didn't get into deep on this because we don't have time. If you go to the VAST website and read our white papers around our disaggregated shared everything architecture, you can get the details on how we scale our performance and capacity independently. This scalability is massive. It's exabyte scale. Total cost of ownership, we're looking at this cluster going in a minimum of 10 years, meaning that you're buying anything and then you just keep adding to it down the road. We're not ripping that out just because we have a new generation in 3-5 years from now. All of these will play nice together. And all of that QLC and stuff in there is also protected for replacement and stuff. So we're assuring that you got a good ride for 10 years. Resiliency, the architecture to the design here in terms of data permanence and uptime is off the charts. It's amazing. And the security side, we've got a lot of enterprise class features in here and many more that keep getting added as we have more and more very, very large financial customers, very large government entities. And so this is something that is already great today and just continues to keep getting better. Now, there was a question that just asked about the secret sauce behind the 10-year warranty. One is we set out to do that from day one, that we do not want those forklift operations. So that is, when we do something today, hey, we're going to have to live with it for 10 years. That's part of it. Another part of it, especially with these QLC drives, is the way that we've architected our storage class memory to take the brunt of the load so that we're not rewriting over and over and over and burning out that wear leveling. But in the event that we got something wrong, we're standing behind our commitment to do those replacements. And with that, we've got a poll up, and I want to thank everyone for attending today. And we are, available for questions. Talk to your VAST rep to learn more for how you can use VAST for data protection, as well as a lot of the other use cases that we support around AI and big data and a lot of the supercomputing applications too.
Excellent presentation, Rob and Jeff. Really appreciate that. Yes, I did bring up the poll question for everyone out there. We do want to get your feedback. What additional information would you like about the VAST data solution? And let's see, maybe just time for a couple more quick questions here to give folks time to respond to that poll. Jason is asking, would the Airlock be considered an offline backup?
It can be considered an offline backup, and it depends on the implementation of this. I think that a truly offline backup would probably be more of an Airlock combined with a remote site. And I think the combination of those two together, you would be able to check all the boxes to say that that truly is an offline backup.
Got it. Brad is asking, what's the value add if they currently use Veeam backup? How could this help them?
I thought we only had a few minutes left. Jeff's smiling. We got a video going here at the same time because I'm a big fan of Veeam, and we run it heavy in our lab. It's kind of a loaded question, but Veeam will do some data reduction. We'll take it even further. We will support S3 operations for like Sober within Veeam. We're an awesome repository. All of those sure backups and instant recovery operations that were intended to spin up live backups only work when your backup media is fast. And so that plays right into VAST's sweet spot. And their new V12 that's coming out with their scalable gateways play right into our scalable architecture with those scalable front-end container nodes. So we can scale it up and combine the two together to achieve whatever SLA that you want to meet, as big and bad as ugly as it can get. And yeah, that's my shortest possible answer, I think.
Awesome. Yeah, good job. Good job. There's still a lot of great questions out there, but I'm afraid we're running out of time here in the MegaCast to get to those live. We'll have to get back to those folks electronically. But again, excellent presentation, Jeff and Rob. Thank you so much for being on the MegaCast today.
Thanks for having us. Really appreciate it.